Hello everyone! So for today's video, we will solve problem number 1 from chapter 3, Total Hydrostatic Force on Surfaces. A tank contains two liquids, half of which has a specific gravity of 1.3 and the other half has a specific gravity of 1.7. A metal sphere with radius of 0.25 meters and specific gravity of 7.2 is submerged such that half of the sphere is in the liquid of specific gravity of 1.3 and other half is in the liquid with specific gravity of 1.7. So in here, we are tasked to solve the following. A. The buoyant force acting on the sphere in newtons. B. The tension of the cable needed to keep the sphere in this condition. So first, we will write all the given. The specific gravity of liquid 1 which is equals to 1.3, specific gravity of liquid 2 equal to 1.7, specific gravity of metal sphere is equals to 7.2, and the radius is equals to 0.25 meters. For our formula here, we have formula for the volume of the sphere which is 4/3 pi r cubed, and substituting the value of our radius which is 0.25, we will get a volume of 0.06545 cubic meter. And for the buoyancy force, it is equals to buoyancy force on liquid 1 added with the buoyancy force of liquid 2. So since the buoyancy force is also equals to gamma multiplied to volume of the object, by expanding this formula, we will get specific gravity of liquid 1 multiplied to rho g, which is also equal to the gamma, multiplied by 0.5 times the volume of the sphere, which is equivalent to 1/2 of the sphere since our figure here is divided into 2, which is in liquid 1 and in liquid 2. Plus the Sg of liquid 2 multiplied to the rho g, which is also the gamma, times the half of the sphere. Continuing with our solution, we will first solve for the buoyant force acting on the sphere in newtons. For the formula of the buoyant force, we have here specific gravity of liquid 1 which is 1.3, rho g or the value of the unit weight is equal to 9,810 Newton per cubic meter multiplied to the half of the sphere which is 0.5 multiplied to 0.06545 cubic meter plus the specific gravity of the liquid 2 which is 1.7 still multiplied to the gamma and the half of the sphere. We will get the value of the buoyant force which is buoyant force equal to 963.1 Newton. Next, we will solve for the tension of the cable needed to keep the sphere in this condition, and it is still in newtons. First, we will solve for the weight. Since the formula of the weight is given by unit weight multiplied to the volume of the object, which is also equal to the specific gravity multiplied to the density times gravity times the volume of the object. So substituting all the given, we will have here weight is equals to the specific gravity which is 7.2, the gamma which is 9,810 Newton per cubic meter multiplied to the volume of the object which is 0.06545 cubic meter. So computing this, we will get the value of weight which is equal to 4,622.87 Newton. Since we notice that the value of the weight is much greater than the value of the buoyant force, then we will need a tension acting upwards in order to maintain the equilibrium of the object. So in order for us to solve for the tension, we will equate all the acting forces to 0. We have here tension minus the weight which is 4,622.87 Newton plus the buoyant force which is 963.1 Newton equated to 0, we will get tension is equals to 3,659.77 Newton. This means that in order to maintain the equilibrium of the object, we will need a supporting tension of 3,659.77 Newton.